This is the second PCB I made. I changed the color in white. And at the back side, it's pretty much the same as the old one. And that is the SMD stencil. All I'm doing is aligning it and putting on some solder paste, which will then be used later on. As you can see, this is the final result. The next step is to set the settings for the hot plate, and I normally put it on 260, as you can see. Once that's done, you can see that the solder paste will melt and the components will be firmly attached on the PCB. Now the next step is to disassemble the old design. Now if you want to see the old design, I'll link a card up in the top right corner. Now once I did all the PCB soldering, the SMD soldering, I decided to add all the other components, the servo pins and the switches and the motors and all that, which I will show you a final version later. This is the new design, printed in PETG. Now I realized that the top section where the PCB sits keeps falling out, so I made this new design which has those grooves, and with this nut, with this screw, so it makes it all fit tightly. Also added those clip-ons that hold the servo firmly in place, because in the old design those clips didn't really work. So all you do is put the servo in, attach that clip like so, and it will be firmly held in place. It will not move out. It's actually a really good design. Came out very good. And then that's what you do for all the others. As you can see, I'm doing the second one, and then the third. Yeah, this robot has 4 legs, so we need 4 clips and 4 wings, 4 brackets, and small brackets. I'll show you all of them later. I haven't changed much of the small and big brackets from the previous design. It's just the base and the clips and the groove in the wings that I've changed. So all the servos are on. You just have to align the cover like so and screw on the nut, and it will stay in place without moving. I might have to just add a bit more of the tolerances, but see, it is not moving, and that is the new PCB. Now I've printed this top cover, but as you'll see in a second, I forgot to make a hole for the Arduino pins, where you connect the USB bootloader to program the Arduino Pro Micro. I'll add that later. These are the 2 base sections, which I'll put my robot on top of while I do some programming and while I attach all the other parts. And that is the new lid that I designed with all the correct pinouts, and it has a snap fit. So no screws required, and I've added those 2 semi half circle whatevers on the side so you can lift it up. And here I am just calibrating the servos. So what I'll do is do a 180 and then manually put the servo horns in the middle, as you can see, and then I lift the servo horn, and then I attach the newly designed wings, and that way I know it's always in the middle, and then I can just slightly change the servo minimum and max maximum in the software, but I know that all the wings will be somewhat in the middle. And that's how the wing is supposed to move. And once you do that, you just have to attach the fishy servers to those holes, in which I realized the holes are a bit too small, so I'll have to make that change as well. But I'm thinking about just open sourcing all of the designs, which you can find in the links below. You can print it out yourself, remodel it, program it yourself. It'll be all in there. But yeah, those holes definitely need to be changed. Yeah, I was really struggling with this one. And then that's the second leg. I'm doing the third one now. In total, it does have 4 legs, so it might take a while. But you only have to do this once. And that is how I program the Pro Micro. Now, initial code, just did something simple, just to see if it works. And yes, these servo motors work. Now, this is the second try. You can see it's somewhat has a walking sequence. But the problem is that I can program the STM Nucleo board to do multi-threading, but on Arduino it's just slightly more complicated, and that is the whole problem with programming Arduino. But otherwise, the inverse kinematics and the calibration of the servo, all the code is in there. It is just when you use the wait function or sleep function in Arduino that makes everything a bit more complicated. But you can see it is starting to walk. It does have that walking sequence. And this is just me trialing it out, different softwares. This one is starting to look somewhat promising. You can see that it does follow a line. But because it doesn't have enough time to swing, the robot will always not move in a straight line.